In this whiteboard animation video, we are going to discuss about equivalence point of a redox reaction. Before going to the equivalence point, we have concern about Nernst equation. We can express Nernst equation as follows. At the 25 degrees Celsius, the equation can be written as the following equation. Simple N is no of electron transferred during the reaction. Consider the following half cells. In this titration, ferrous ions convert to ferric ions concerning cerium 4 plus iron convert to cerium 3 plus iron. In this example, we're going to discuss titration of cerium 4 plus iron and iron 2 plus iron. The ferrous solution is kept in the flask. The cerium 4 plus solution is kept in the burette. We have to focus on the equivalence point of a redox reaction. The equivalence point is the point at which the reactant reacts according to stoichiometric ratio. According to the Nernst equation for iron, equivalence potential, EQ, can be written as below, which is in equation 3. Also, we can write the equivalence potential, EQ, for cerium as in equation 4. By adding equations 3 and 4, we can find the value of the equivalence point potential of the reaction. At the equivalence point, the concentration of each species should satisfy the below conditions. So, the equivalence point can be calculated as follows. Let's look at the following half cells. In this titration, N permanganate converts to manganese 2 plus ions. Ferrous ions convert to ferric ions. The ferrous solution is kept in the flask, and the permanganate solution is kept in the burette. According to the Nernst equation for permanganate, we can express equivalence potential, EQ, as in equation 7. Also, the equivalence potential, EEQ, for iron can be written as in equation 8. By adding equation 7, which is multiplied by 5, and equation 8, we can find the value of the equivalence point potential of the reaction. At the equivalence point, the concentration of each species should satisfy the below conditions. So, the equivalence point can be calculated as follows.